All right, my goal is for this Edpuzzle to go fairly quick just because I already wrote the answers on here. Change. There we go. So I'm not going to talk about each question. So you very well may have to pause this to wait, and if you need to correct a lot of them, to correct them, and then move on and hit play and keep watching. But I will talk about a few things on each section. One thing with this first section is be careful with ones like this where there is not parentheses there. So we really think about this after we bring it down here. We think about it as -1 times 2 to the 4th. So that's why that negative stays with it. That is different from this. If the negative is inside the parentheses, then we have -2 written out 4 times, and that would end up being +16. So be careful with whether we have parentheses or whether we don't. On this next section, one trick, we can't have the 4th root of something and have it be negative. So not possible or error or undefined even I would take, but not possible is just fine. So be careful if I'm trying to trick you. We can't take the 4th root of something that is negative. It would never work. We can't multiply something by itself 4 times and have it turn out to be a negative number. That would always be positive. Make sure with these ones like 9 through 12 that we're showing these steps on the test. You will not get credit if you do not show steps where you're rewriting it and then simplifying. On this next page, it didn't tell you had to necessarily explain, but it's a good habit and it will be there on the test. Make sure that you give an explanation. If it's exponential, show that we're multiplying by 5. If it's linear, or if it's not exponential and you're just saying it's linear or whatever, make sure that you're showing it's adding by 4. If there's no pattern, say it looked like it was doing this at first and then it stopped. So let me know that as well. Down here, these are all about plugging them into your calculator and looking to see what line we approach but never actually cross. We're always going to be above our asymptote. We're going to be everything greater than, or it's going to be everything below the asymptote. So looking at our graph, using our table to figure out where that asymptote is, will help us decide that for 11 through 14. Again, if you need more time to look at these, pause it, look closer at what I have on here, and then keep going. I'm going to try to go quickly for those of you that are picking this up quick. A few things. Make sure, first thing, we read all the directions, that we label at least 3 points. They don't have to be the same points that I have here, but make sure you have 3 points labeled. One of those 3 must be the y-intercept. Make sure that you write the asymptote as an equation. It's a y equals equation. It's a line on our graph. So we need to make sure. Some people kept writing it as y is greater than, like almost the same as our range. But make sure we write it as a y equals equation. And then we have some domain and range again. Down here, we like exponential growth. We can do 1 minus the number in parentheses to get our rate, and then we write it as a percent. This does say 1.5%. Sorry, that's a little blurry. And we're pretty good about writing these equations. If you first have a step, that's y equals 300, 1 plus 0.5. Whoops. If you have this first and then go to here, great, no problem. But your final answer should be in this form. Next, exponential decay. Oops. Uh-oh. -1/2 for me. I'm not going to take the time to do this on the Edpuzzle, but I'll update some things. It's more than -1/2. That's 1/2 per problem. -1.5. But for the first part, give the initial amount, your A value. Here they're trying to trick you, it's just 1, and then give the rate of decay. Remember here we can do 1 minus the number in parentheses, write it as a percent, that'll give us the rate of decay. And I don't feel the need to talk about these. They're in our equation, we would give the initial amount 1 minus the rate, and then we'd simplify to here. Make sure we write that rate as a decimal. See, 11 is linear, so it would not be exponential growth or decay. 12 would be decay. It's multiplying by 2/3, which is a little bit difficult to see, but that's where the second term over the first term can help us out. In the 6.5 stuff, make sure we get bases that are the same. Once we have bases that are the same, we know that we can cross out the bases and we can solve. Also make sure that we're distributing here. When we cross things out, that we distribute the 2 to get 8 and 14. Here, that we distribute the 3 to get -9 and -12. But when we rewrite those, if there are 2 terms up in the exponent, we've got to make sure that we distribute. I don't need to talk about this section here, determine if it's arithmetic, geometric, or neither. I think those we can look at and we can see what's going on. Give the next 3 terms. First, you have to identify the pattern, then be able to give the next 3 terms. Write an equation for the nth term. This would mean it wants an explicit equation. So I can explicitly tell you, without swearing, that you plug 6 into the equation and you get what the value is at 6. With these, we have to be careful. Well, they told us they were all geometric, so we knew that it was in the form a sub n equals a sub 1 to the, or times r to the n minus 1. All right, almost done. Give the first 6 terms. Remember, they always give you the first term. So they give you the first, you really need to find the next 5. They tell me I'm adding 3 here every time. Subtracting 8, multiplying by 5, multiplying by 2.5. Those should be calculator problems. Put in the first term, apply what's happening, keep applying what's happening. A recursive rule would be giving the first term and then saying, okay, how do we get the rest of them? That's where somewhere in here you'll have that a sub n minus 1 notation. I want to make this super, super clear with these, and you can correct this after I talk about this. When we have an explicit rule, recursive always looks like this. An explicit rule, if it's geometric, it's going to be in this form. If it's arithmetic, it's going to be in this form. So when it asks us to write an explicit rule, we first have to determine, is it geometric or arithmetic? And then once we know which one it is, then we use the appropriate formula. If it's arithmetic, we need to make sure we distribute and we simplify so it's in a form that looks like slope-intercept form. But I don't want us to get confused that we see explicit and automatically think it's one of these 2, or we use one of these every time. Nope. This one's arithmetic, so it's got to be in this form. This one's geometric, so it's going to be in this form. If we're having a hard time with 9 and 10, plug a couple numbers in. Plug 1 in, see what you get. Plug 2 in, see what you get. Plug 3 in, see what you get. And then you can start to identify the pattern. Don't get tricked with number 10. It's very common for people to say -7 or 3 are our first term. Nope, we need to plug 1 in, and then we can see that -4 is our first term. I know that was quick. If you have any further questions, make sure that you send me an email. Otherwise, I hope this helps and that we will be prepared for our test tomorrow. Oh, wait, no, I'm not done. Psych. Compound interest, almost forgot. Take a look at these. I'm not going to walk through every single one of them. Just notice that we are changing how often it's compounded. Semi-annually would mean n is 2. Let's see, this one we were semi-annual again, and this one we were monthly again, just like the first one. So pay close attention to how often we're compounded. Okay, now I'm done. Now, let me know if you have any questions. I hope this helped you prepare for your test. See you tomorrow.